Welcome to another video. Today we are looking at how nuclear power plants work, the benefits and drawbacks. Nuclear power plants are complex facilities that harness the energy released from atomic reactions to generate electricity. They operate on the principles of nuclear fission, where the nuclei of certain isotopes of heavy elements such as uranium-235 or plutonium-239 are split into smaller parts, releasing a significant amount of energy. Isotopes being atoms with the same number of protons but different numbers of neutrons. This video explores the fundamental workings of nuclear power plants, including the fission process, the components of a nuclear reactor, and the conversion of nuclear energy into electrical energy. Nuclear fission is the core process behind the operation of nuclear power plants. It involves the splitting of an atomic nucleus into smaller parts, usually neutrons and other subatomic particles, along with a considerable amount of energy. When a neutron collides with the nucleus of a heavy atom like uranium-235, the nucleus absorbs the neutron and becomes unstable. This instability causes the nucleus to split into two smaller nuclei, releasing additional neutrons and a substantial amount of heat energy. The released neutrons can then initiate further fission reactions in nearby nuclei, creating a chain reaction. In a controlled environment like a nuclear reactor, this chain reaction is maintained at a steady rate to ensure a continuous and stable release of energy. A nuclear reactor, the heart of a nuclear power plant, comprises several critical components designed to initiate, maintain, and control the fission process. Fuel rods. These rods contain the fissile material, typically uranium-235 or plutonium-239. The fuel is often formed into ceramic pellets and stacked into metal tubes, which are bundled together to form fuel assemblies. Control rods. Made of materials like boron, cadmium, or hafnium, control rods absorb neutrons and regulate the fission process. By adjusting the position of these rods, operators can control the rate of the chain reaction, ensuring it remains steady and safe. Moderator. The moderator, often water or graphite, slows down the neutrons produced during fission, increasing the likelihood that they will cause further fission events in other fuel atoms. Coolant. The coolant, typically water, circulates through the reactor core to absorb the heat generated by fission. This heat is then transferred to a secondary system to produce steam. Pressure vessel. The reactor core, control rods, and coolant are housed within a robust pressure vessel designed to contain the intense heat and pressure generated during the fission process. The heat produced in the reactor core is the primary source of energy in a nuclear power plant. This heat is used to generate steam, which drives turbines connected to electrical generators. The process involves several steps. Heat transfer. The coolant absorbs heat from the reactor core and transfers it to a secondary water system in the steam generator. Steam generation. The secondary water system, heated by the primary coolant, produces steam. This steam is then directed to the turbines. Turbine operation. The high-pressure steam spins the turbines, which are connected to electrical generators. As the turbines rotate, they drive the generators, producing electricity. Condensation and recirculation. After passing through the turbines, the steam is condensed back into water in a condenser. The condensed water is then recirculated back to the steam generator to be heated again, continuing the cycle. Safety is paramount in the operation of nuclear power plants. Numerous measures are in place to prevent accidents and mitigate their impact should they occur. Containment structures. Thick, reinforced concrete and steel structures enclose the reactor, preventing the release of radioactive materials in the event of an accident. Multiple redundant safety systems. Redundant and diverse safety systems, including emergency core cooling systems, ensure that the reactor can be safely shut down and cooled under all conditions. Regular inspections and maintenance. Continuous monitoring, rigorous inspections, and routine maintenance are conducted to ensure the plant's components are functioning correctly and safely. Nuclear power plants also offer significant environmental benefits compared to fossil fuel-based power generation. They produce minimal greenhouse gas emissions during operation, making them a low-carbon energy source. However, they do generate radioactive waste, which must be carefully managed and stored to prevent environmental contamination. Nuclear power plants are sophisticated facilities that utilize the immense energy released from nuclear fission to generate electricity. Through a series of meticulously controlled processes and advanced safety measures, they provide a reliable and low-carbon source of energy. As the world continues to seek sustainable and clean energy solutions, nuclear power remains a crucial component of the global energy mix, offering both opportunities and challenges in its continued development and deployment. Thank you for watching this video.